Hello friends, now we are starting the second chapter in physics, that is electrostatic potential and capacitance. In the first chapter, electric charge and electric field, we already seen the physical quantity electric field intensity, which used to describe the electric field due to a charge. We have another quantity, a scalar quantity, which also used to describe the electric field due to a point charge or charge distributions. That quantity is known as our electrostatic potential. Let us see in detail what is electrostatic potential. For that, suppose we have a charge which is placed at a point O. A positive charge plus Q is placed at a point O. And the region around this charge is its electric field. Suppose A and B are two very near points in its electric field. A and B are near points in its electric field. Suppose we have a very small test charge which is placed at A. Q0 is a very small test charge which is placed at the point A. Comparing to the plus Q, it is too small in magnitude. Otherwise, it will disturb our source charge. So, plus Q0 is a very small positive test charge. Now, suppose we are trying to move the charge Q0 from A to B. There is an electrostatic repulsive force of plus Q here, source charge. In order to overcome that repulsive force, you have to apply a very small force, or you have to apply some force to move the charge from A to B. It should not be a large force, otherwise the charge will be accelerated. Without any acceleration, suppose by applying a force, we are moving the charge from A to B. So for that, we are doing some external work. Suppose the work done against this electrostatic force is WAB. It's a work required to move the charge from A to B. Now, if you are finding what is the work required to move a unit positive charge. So to find the work required to move a unit positive charge, we are dividing the total work by Q0. So this is actually the work required to move a unit positive charge from A to B. So we can write this one as the potential difference between A and B. That is, actually this is the difference in potential energy of the charge Q0 when it is moving from A to B. So that we call it the term as potential difference in electric field. Potential difference in electric field between any 2 points is defined as work required to move a unit positive charge from one point to another point. So the potential difference between B and A, we are writing like this way. Potential is denoted by a symbol V. Potential difference between B and A is defined as VB minus VA. Potential difference. Difference in potential energy when the charge is moved from A to B. Difference in potential is equal to work required to move a unit charge from A to B. This SI unit is joule per coulombs. Okay, it's also known as volt. It's named after the scientist Alexander Volt. The unit of the potential difference is taken as either joule per coulombs or volt. Okay, now suppose the point A is situated far away from our source charge. For convenience sake, it is at infinity. But the influence of this charge at infinity will be negligible. So we can say potential at infinity due to this charge will be 0. So that's why we are taking that VA is equal to 0. If we are substituting VA is equal to 0 in this equation, we get what is the work required to take the charge from infinity to the point B. What is the work required to take the charge from infinity to the point B? That's VA, substitute VA is equal to 0 at infinity, potential is 0. So we are getting potential at point B. potential at point B is equal to VB is equal to work required to bring the charge Q0 from infinity to the point B divided by Q0. This is actually what? The work required to bring a unit charge to the point B from infinity. That is the potential at the point B. So see, how can you define the potential at a point? Potential at a point can be defined as the work required to bring a unit positive charge from infinity to the given point. Let us see how you have defined this potential difference between these 2 points. Potential difference between 2 points is defined as work required to move the charge from A to B. Work required to move a unit positive charge from A to B. And the potential at a point is defined as the work required to bring a unit positive charge from infinity to the given point. And potential, let us study potential is also measured in volt. And let us see, when you say potential at a point is 1 volt, you can say the potential at a point is 1 volt if work done is 1 joule for bringing a charge of 1 coulomb. If 1 joule of work required to bring a unit charge, unit positive charge, that is 1 coulomb of charge from infinity to the given point, we can say potential at that point is 1 volt. So define 1 volt. 1 volt is the potential at a point, or potential at a point is said to be 1 volt if 1 joule of work is required to bring 1 coulomb of charge from infinity to the given point. Or let us see, how can you define the potential difference between 2 points as 1 volt? If 1 joule of work is required to move the charge from A to B, to move a 1 coulomb of charge from A to B. See, the potential difference between 2 points is said to be 1 volt if 1 joule of work is required to move 1 coulomb of charge from A to B. That's the potential difference between the 2 points. Hope you will understand the concept of potential, electrostatic potential. Thank you.